Well, good morning. Thank you, Arthur. I want to welcome everyone to today's event on Canada's Quantum Valley, the integrated pathway to the high-tech future. This event is part of Cyber Week here in Washington, which is growing in importance each year as more and more people, both in the policy world and beyond, become aware of the absolutely critical importance of cybersecurity to our nation's infrastructure and to our national security and to our commercial prosperity. Let me say that this area of the intersection of technology, policy, and strategy is one that we at Hudson Institute have been involved with ever since our founding in 1961 by the late great futurist and strategist Herman Kahn. Herman Kahn was critically aware of the transformative impact of technology on the world we live in and on policy more broadly. And as Herman looked to the digital age, looked to the information age, and eventually to the digital age, he brought immense insights in these areas. And I think similarly today, Arthur Herman, who leads Hudson's Quantum Alliance Initiative, is doing the same as we stand on the precipice of this breakthrough technology that is really going to be transformative in many fundamental ways. The Quantum Alliance Initiative was started over a year ago to identify and promote policies that will allow the United States to take full advantage of developing quantum technologies, understanding that we live in a very competitive world, a world of strategic competition for many countries, including China. Just, I guess it was less than 2 weeks ago, we had the Vice President of the United States who gave a speech here on a monumental speech on U.S. policy towards China and the area of high-tech competition, intellectual piracy, other areas stressed by the Vice President. And I think it's important for the United States that we need a robust national strategy in quantum, which includes computing, sensing, and communications, really to be prepared for this new age, to face the competition in this age. And so our conference today is going to focus on important steps that our neighbors and friends to the north in Canada have taken in Quantum Valley, which offer really, I think, as we'll learn today and as Herman has stressed a blueprint for how to create a national quantum ecosystem in the United States. We're very fortunate to have Mike Lazaridis with us here today, founder of BlackBerry, and also Ian Stewart, the president of the National Research Council of Canada, to talk about how Canada is meeting this challenge and what the lessons might be for the United States. And I now have the distinct pleasure and honor of introducing Dr. Arthur Herman, Hudson Institute Senior Fellow, who will introduce Mike Lazaridis. Let me just simply note that Arthur is not simply one person, he's actually two people simultaneously. He is a brilliant historian, author of 9 books, one of which was a Pulitzer Prize finalist, Gandhi and Churchill. He's the author of Freedom's Forge, which talked about how American industry won World War II. He is most recently the author of American Warrior, a must-read on Douglas MacArthur, and 1917, which looks at the implications of the thought of Lenin and Wilson for our times. But Arthur is not simply this brilliant historian, he's also a brilliant analyst of how technology affects policy. He's taken a very critical role in important national debates in our country about how to face the North Korean challenge and how to promote increased defense technology cooperation between the United States and its allies and partners. So without any further ado, allow me to turn it over to Arthur Herman. Thank you very much.
For joining us. I want to give a warm welcome, though, to those of you who have come over here on a chilly, Canada-like spring day or fall day. And also want to thank all of you who are watching as we live stream this event at our Hudson website. This is, as Ken mentioned, an enormous pleasure and honor for us to have Mike Lazaridis, and the team from Quantum Valley, Canada here, as well as Ian Stewart, to talk about what Canada is doing and has been doing in the area of quantum information science and quantum technology. Now, I'll leave it to Mike and to other panelists to say more about just how important from a technical and scientific point of view that quantum revolution is and is going to be. The thing to stress always in this is that you ain't seen nothing yet in terms of the kind of range and power and potentiality of information technology as we move from the digital age to the quantum age, as we unleash the power of quantum physics and quantum mechanics in the realm of information technology, and the way in which subatomic particles, from photons to quanta, will become harnessed in order to unlock some of the most important secrets in the universe, as well as some of our own most important secrets through the potentiality of decrypting today's public encryption systems. This, of course, is one of the reasons why the quantum revolution has begun to gain the focus and attention on the part of policy analysts, not just the United States, but around the world, including Canada. But it's also one of the aspects, just one of the aspects, of how quantum technology is going to transform our daily lives, transform how we think about national security, and indeed how we think about the relationship between our countries and other countries around the world as this new power is unleashed in the area of quantum computing, and quantum communication, quantum sensing, and quantum optics. We'll say more about that. You'll hear more about it as the panels proceed. But let me say a few things about our keynote speaker. Mike Lazaridis is a name which in the United States is immediately linked to a company called BlackBerry. And for those of us who used BlackBerry, it was our indispensable tool for communication, not just in our own country, but around the world. The seamlessness with which a BlackBerry device was able to take you, as it took me and my wife, from the United States to Israel to Europe without missing a beat, without having to look for roaming and absorbing roaming charges, was a miracle in itself. But also the fact that this technology company was able to arise not in Silicon Valley, not as a result of American venture capital or the usual suspects that we see involved in information technology, but arose in Canada, arose in a place in which, from American perspective, would seem to be a minor player in the realm of high tech and the high tech future. And yet Mike Lazaridis and his team were able to bring this about and really point the way to the way in which we are all now, the role of interconnectivity via smartphones. I think Mike Lazaridis deserves high marks as one of the great pioneers in that area, and who leaves his mark to this day, not only on the number of people I know, including high-level figures in the Defense Department and Defense Science Board, who still cling to their BlackBerry as their emergency bat phone, as it were, when they don't know all the other devices may fail them in a crisis. But also that all across this country, I suspect, there are still those who gave up their BlackBerries, who now are looking and in touch with former BlackBerry owner support groups as a way in which to overcome the sense of trauma and loss of having to shed that essential technology and to move on to its imitators and emulators. But I'm not here to talk about Mike Lazaridis, co-founder of BlackBerry, but about something else. About Mike Lazaridis, who in the 1990s began to look out across the horizon of high tech and the possibilities for Canada, a country which he loves deeply and is deeply connected, and began to think about the ways in which Canada could become not just a follower in high-tech industry and information technology, but actually a leader. And the area in which he focused and he thought about that future would be quantum. quantum technology, computing, and the enormous possibilities that Canada could realize if it moved quickly enough and with sufficient agility in this area when the rest of the world was still waking up to the possibilities of digital technology. Now, this, to me, constitutes real vision. This constitutes, in my mind, the kind of vision that we in the United States need to start thinking about when we think about the quantum revolution and quantum technology. A revolution which needs to be addressed not just in the private sector, whereas I think as many of you know here during Cyber Week are aware, if you're aware of quantum technology at all, you're aware of the efforts that companies like IBM and Intel and Google and Microsoft are making, and the enormous strides that they're making in that area, as well as mid-sized companies like Rigetti Computing. But from the point of view of American policy, in terms of a national quantum strategy, what we are finding is that there are other countries around the world who've been well ahead of us. The United States is just beginning the process of coming to realize the necessity of a national strategy. We have at Congress right now a bill, the National Quantum Initiative Act, which devotes money and resources towards advancing quantum technology. The White House has organized the first quantum summit just a couple of weeks ago to discuss the ways in which we can bring together information technology and other areas to address this issue of importance to national security and our own economic security. But there still remains a great deal to be done. There still needs to be a lot of thinking about holistically about how United States and its key leaders in this area need to come together to think about a broad, comprehensive strategy in this direction. And this is one of the things, as founder of and director of the Quantum Alliance Initiative, that I immediately recognized with regard to Canada. That Canada had thought these things out, and that Quantum Valley, as it's called in Canada, represents a model, a paradigm that the United States and other countries can look to in this highly competitive technological race. Canada as the model for it, and then when I was up in Canada in May, that Mike Lazaridis was the perfect spokesman for it. Mike Lazaridis, the man whose vision is now unfolding and is now directing in ways that we could all follow and that we're all going to learn about him. Among his many honors, of course, his fellow of both the Royal Societies of London and Canada. He's been named to both the Order of Ontario and the Order of Canada. He was listed on Maclean's honor roll as a distinguished Canadian in 2000, honored as the Globe and Mail Nation Builder of the Year in 2010, selected as the 2013 Visionary of the Year Award by the Intelligent Community Forum, and awarded the Ernest Manning Principal Prize, Canada's most prestigious innovation prize. Ladies and gentlemen, it's my honor and privilege to introduce to you and to have your chance to listen to Mike Lazaridis.
Thank you, Arthur. Wow. I had to organize things a little bit. Sure. Well, thank you for a great introduction, Arthur. And I want to thank everyone for joining us today. It's, you know, it's one of those things that's intimidating even to someone who's been in this field for so long, to realize that you're being asked to talk about something that you've been working on for nearly 20 years, and you have about 30 minutes to do it. So for all of you in the audience, I'm going to have an exam at the end, and I'm going to be asking, see if you've caught up. I would like to thank the Hudson Institute as well for organizing this event. and for inviting you all here and getting us together to talk about this. Because the second quantum revolution is an exciting and large-scale global industry based on new quantum technologies. If you read almost any government report or media article on science innovation, you will quickly realize that the second quantum revolution has already started to take shape with massive investment around the world. What's driving this new industry are basic principles of quantum mechanics that make possible new transformative technologies that can do things that previously were simply not possible. And although it's early days, we can already see that these new quantum technologies will have broad application over virtually every industry and virtually every facet of everyday life. Now, I've been asked to describe to you the effort that we started almost 20 years ago to build a broad-scale quantum ecosystem in Waterloo, Canada. But before I begin, I want to take this opportunity to acknowledge a very important achievement for my alma mater. Of course, I'm speaking of the recent announcement of the University of Waterloo's Professor Donna Strickland's Nobel Prize in Physics. We used Dr. Strickland's discovery in so many of our experiments in the Quantum Valley, not to mention laser surgery, eye surgery, cancer research, as well as all areas of industrial design, manufacturing, and production, and countless other precision uses. What wonderful recognition and a very much deserved award for Dr. Strickland. I'm very proud, both as an alumnus of UW and as a supporter of physics in Canada. Now, in the early 80s, I was fortunate to obtain some insights regarding the transformative potential of quantum during my studies in physics and engineering at the University of Waterloo. In 1982, my physics class was studying a quantum physics experiment that was just published by Dr. Alain Aspect of France, literally that year. Dr. Aspect had achieved the first reliable experimental proof of Bell's theorem. In doing so, he once and for all showed us that the world was quantum, that the classical world of physics and everyday experience was an approximation, if not an illusion. Now you have to understand, for those of us that were in that class, when our physics teacher put that up on the board and started showing us the experimental results and trying to explain to us what it was, we started arguing with the professor. And we started saying things like, that's impossible. The world doesn't work like that. And what I have to tell you is that the teacher's smile got bigger and bigger because he realized that we had actually understood what he was talking about. That's how transformative this is. It's not just, a technology, it's a completely new view of reality. Now, quantum information science was just beginning, and it implied that information, energy, and matter could be related. Just like thermodynamics showed us that heat and energy were related, just like Maxwell's equations showed us that electricity and magnetism were related, and relativity showed us that energy and matter were related, quantum mechanics had showed us, starting to tell us that information, matter, and energy were all related in a profound way, and that we could take advantage of that. This experience opened my eyes to the second quantum revolution, and its promise to be even more significant to humanity's future than the first quantum revolution, which today we call the Silicon Age. So many of my colleagues and I got together in 1999 with a 25-year strategy to help position Canada to intercept the second quantum revolution. Now, our experience in building BlackBerry gave us significant insight on the importance of a broad-based strategic approach to the undertaking. We learned a lot about what worked and what could be improved upon. And we didn't stop there. We spent a lot of time looking at other models in Canada and around the world. We even researched historical models, including the early experiences at places like Bell Labs and Silicon Valley in the early 40s. To help position Canada to intercept the second quantum revolution, we decided to establish a broad-based quantum research and technology development ecosystem in the Waterloo region of Canada under the brand Quantum Valley. We realized that we needed to recruit and retain the very best researchers, engineers, and entrepreneurs to Waterloo. To do that, we needed to build brand and density in theoretical physics, quantum experimentation, fabrication, and industrial commercialization. The cornerstone of the Quantum Valley is the successful public-private partnership that has united private industry, philanthropy, and leading Canadian universities with the governments of Canada and Ontario as long-term investors in the development of a quantum industry in Canada. Now, the slide you're looking at shows what we built as part of the Quantum Valley ecosystem. It also shows how we strategically built the various components in close proximity to ensure collaboration and synergies. And a lot of that in the center there is the University of Waterloo, and there's also Laurier University, and we even have a community college, so it's a very academic community. Let me tell you a little bit about some of the core components in the ecosystem. Now first, it probably goes without saying, but it's something that we have to always keep in mind that, and it's a saying that we repeat often in the Quantum Valley, that today's theoretical physics is tomorrow's technology. And with that, you know, the corollary is also true, that the theoretical physics of the last century is the basis for almost all our technology and value creation in the last century. And it's something that we always have to keep in mind, because without those insights into how reality functions and our ability to actually measure and control those interactions is what drives a lot of new technology that completely changes things. It no longer is a zero-sum game when theoretical physics figures out a way to explain a fundamental physical property. So fundamental research is the necessary first link in the innovation chain. We determined that Canada needed a world-class theoretical physics institute to focus on quantum mechanics and space-time, the two big discoveries in the last century. World-class researchers at Perimeter Institute for Theoretical Physics advance existing theories, physics theories, and develop new theories that will be the basis for new experiments and new technologies. Most importantly, they are plugged in to the world science research and experimental effort. They are our inside information. They quickly inform and direct our Canadian research community, universities, students, and industry where to look and where to invest resources. The interaction of these researchers and their students with Canadian universities and Canadian industry give Canada an early mover advantage that is crucial in today's competitive global marketplace. PI also contributes to Canada's global brand, inspires our citizens, and helps recruit and retain talent. 7 years ago, we added the Stephen Hawking Center at the Perimeter Institute for Theoretical Physics. We were all saddened by his passing earlier this year, but he clearly saw the importance of Perimeter to Canada and the world. Now, following PI, we knew we also needed a world-class experimental quantum physics institute that focused on advancing foundational principles in quantum information. Top experimentalists from around the world at the Institute for Quantum Computing at the University of Waterloo undertake experimental work that helps develop foundational principles in quantum technologies and applications that are the basis for new technologies, new products, and new businesses. They leaven other disciplines like engineering, computer science, mathematics, physics, chemistry, and biology through interdisciplinary research and interaction with students and industry. We purposely put that building at the center of campus, and there are literally bridges and tunnels connecting to all the science and math buildings around that institute. Students actually walk through there, and we purposely put windows so they can see the fabrication labs and the people inside building things to inspire them. When we started, the Perimeter Institute and the Institute for Quantum Computing were nothing more than ideas. Today, these organizations are considered among the largest centers in their respective areas. In the process, they have helped to establish Canada as a global leader in quantum research and the development of quantum technologies. And we started Quantum Valley Investments to privately support the first innovative ideas coming from entrepreneurial researchers at IQC. It's hard to make a quantum pitch. I don't know if there really is an elevator pitch for a quantum breakthrough. It involves a lot of equations on the board. Honestly, it really does. QVI provides access to much needed large-scale startup capital to develop quantum startups in the Quantum Valley. And we knew we needed to take a leap of faith with new quantum opportunities and to provide informed, patient capital. We also knew that this type of capital was not necessarily available from conventional venture capitalists or strategic investors. In fact, as our strategy, our early investments and experience has helped these quantum startups attract more traditional venture capital as they developed. To date, QVI has strategically invested in a number of operating businesses. In each case, QVI has partnered with world-class researchers, including entrepreneurial researchers at IQC, and experienced operators to establish companies that will develop transformative technologies for global markets. Later in my remarks, I will talk about Icera Corporation, one of our exciting quantum companies that has already developed quantum-safe encryption technology. This afternoon, you'll hear from Scott Totsky, Icera's CEO and co-founder. Scott will explain to you the very real and serious risk that quantum computers pose to our existing encryption and authentication infrastructures. He'll also explain how technologies like those developed by Icera will help us to respond meaningfully to this impending risk. And finally, we also took a strategic approach to application-focused research and built the Quantum Valley Ideas Lab to provide infrastructure and personnel to commercialize quantum breakthroughs into technologies that can be licensed by industry. It takes a completely different infrastructure to support this kind of incubator. Ideas Lab is a not-for-profit quantum technology incubator. The exclusive focus of Ideas Lab is developing new quantum technologies that will form the basis for new products and new companies. By doing so, it addresses the gap between foundational research done in academic research labs and commercialization. Ideas Lab provides a necessary advanced infrastructure and expertise to fast-track the commercialization of academic quantum discoveries and advances. For each project that Ideas Lab pursues, it'll establish a dedicated team of researchers and technical staff that will undertake the R&D necessary to create compelling new quantum technologies for commercialization. You can think of Ideas Lab as a modern-day Bell Labs or Stanford Research Institute that is focused on quantum technologies. And another useful model that we applied is the Broad Institute at MIT and Harvard. Now, at this point, you might be asking, okay, great, how are you doing? Well, it's still early days, but there are some indicators to demonstrate that we're achieving the kind of traction and progress that we had hoped for. Now, here's an example of some very positive media commentary we have received from Bloomberg Week. It was actually published earlier this year. Lazaridis and Freegan led recruitment and development at 3 research organizations: the Perimeter Institute for Theoretical Physics, the Institute for Quantum Computing, and the Waterloo Institute for Nanotechnology. Those efforts have attracted prominent physicists and made Canada an outsized force in the field which the US and China typically dominate. Now, here's a report issued by the UK government a couple of years back that ranks the top quantum commercialization efforts around the world. And Canada is in the top 5, including patents. Quantum Ideas Lab is now commercializing its first quantum technology. And established venture capital, strategic investors, and other funds are actively looking to invest in a number of the companies in the Quantum Valley. So we've made some progress, but we still have a long way to go. Now, although the second quantum revolution will be a major driver of innovation and economic value for decades to come, real products and businesses are already starting to be developed. We also believe that there will be meaningful technologies over the next few years, and certainly over the next decade. The second quantum revolution will impact all technologies and industries. That's the key takeaway. I'd like to describe some of the quantum technologies that are being developed in the Quantum Valley and at other quantum labs around the world, and give you a sense of, a very speculative timeline. So the first one that we're investing a great deal in, and so are other initiatives around the world, is quantum sensor technologies. Now, one of the challenges of building a quantum computer is that the processor is very vulnerable to outside influence. And so the same thing that makes the materials in a quantum computer extremely sensitive to outside stimuli can be taken advantage of to make incredibly sensitive and precision sensors. So quantum sensor technology that offers precision and sensitivity that are orders of magnitude better than their classical counterparts. That's another key takeaway. In a lot of technologies today, we get pretty excited about a 50% increase in performance. And we're talking about orders of magnitude greater performance and sensitivity. They'll allow the sensing and identification of single atoms and molecules and measure biology non-invasively. They'll help turn smartphones into the fictional tricorder of Star Trek. I mean, that is an incredible opportunity if we could get all this integrated in ways that will completely revolutionize healthcare and healthcare management. These sensor technologies, which are already being developed for commercialization, will have major impact in a large number of industries, including healthcare, medical diagnostics and imaging, mining, navigation, energy, communications, the environment, and defense. And these are just some of the possible uses. So the whole idea that the second quantum revolution will impact all technologies and industries is something to keep in mind. New quantum materials will use topological and layered geometries of atoms to change the way they interact with electric and magnetic fields, making them perfect conductors of quantum properties such as spin, or even making them invisible. New quantum materials may help us improve the performance and manufacturability of high-temperature superconductors for more efficient power distribution of national and international DC grids. This is an area that holds enormous promise for science and industry, as material science defines a lot of what is possible today. Now, here's something that we're also very excited about. It's the whole idea of a quantum simulator. In fact, that's what got the whole quantum computing revolution started when Richard Feynman realized that we won't be able to simulate the interaction of small numbers of atoms. We can simulate the number of atoms interacting in very large numbers with computational fluid dynamics. So, we've kind of moved past the wind tunnels and water testing years ago using large supercomputers running computational fluid dynamic programs. But we had no way back in the early 80s, when Richard Feynman identified this problem, that to simulate smaller numbers of atoms. And that's become a very interesting thing. But he proposed that if we could build a quantum simulator or a full quantum computer, that we'd be able to simulate exactly the behavior of those atoms. Now, it's very hard. Remember what we talked about, that the quantum world is very different. And the quantum interaction of atoms is such that there ends up being an infinite dimensional matrix of their potential interactions. And so it's completely impossible to simulate the interaction of a smaller number of atoms for understanding surfaces, catalysts, different materials. So quantum simulators give us the promise that they'll be able to, for the first time, simulate matter in an exact way. These simulators will transform the way that we undertake research and will dramatically enable and accelerate the discovery and development of new materials, new catalysts, and a whole new processes. Imagine being able to simulate atomic and molecular interaction exactly with a computer and not having to perform complex, error-prone, laborious, and costly physical experiments. We're already starting to see some exciting developments in quantum simulation technology, and researchers predict that we'll have major advances in the next 5 to 10 years. Now, the thing that keeps getting all the press and publicity is the general purpose quantum computer. And it's largely considered the holy grail of quantum technologies. The general purpose large-scale quantum computer will be one of the most disruptive and transformative new technologies of this century. Predictions on the development of a general purpose quantum computer vary dramatically, as you can see from the slide. Since it's Cyber Week, I thought it's important to talk about the impact of quantum computers on cybersecurity. Now, as you know, much of our existing authentication and encryption is based on factoring prime numbers or other math-related structures such as RSA or elliptic curve. Now, elliptic curve was a significant part of BlackBerry's security strength. Physicists have confirmed that when a large-scale quantum computer is invented, it will be able to break these encryption methods quickly. In fact, the first quantum algorithm, named after its discoverer, Dr. Peter Shor, in 1994, demonstrated the enormous and disruptive power of quantum computing. The Shor algorithm, when run on a quantum computing system, dramatically accelerates the speed at which a quantum computer can factor very large prime numbers. It literally takes advantage of what I said before, that infinite matrix of interaction to perform all possible calculations at once. The Shor algorithm, unfortunately, most of our current and future security infrastructure is predicated on the inability of classical computers, no matter how large, to quickly factor very large prime numbers. Now, I'll leave it to the physicists to debate the exact time frame when we will have a large-scale quantum computer. But one thing is for sure, there are a lot of brilliant researchers and large amounts of resources from around the world focused on developing a general-purpose quantum computer. So I wouldn't recommend that you rely on some of the longer predictions. Now, the timeline becomes even more uncomfortable for organizations like banks, governments, and large corporations that have longer transition times. Think about your systems at your organization and how long it takes to implement a routine patch. Now imagine swapping out your entire encryption authentication system. I'll let that sink in a bit. Fortunately, there are a lot of smart people working on solutions to this problem. As you'll hear later, Icera's Radiate security solution suite is an example of advanced quantum-safe encryption to create networks and connected devices that can withstand an attack from a quantum computer. But what makes it really interesting and truly valuable is that it's software that can be embedded in your existing systems. Icera has also developed technology that allows you to do it in a phased-in, agile solution. So you don't have to do it all at once. Take your time and make sure that your entire organization eventually becomes resistant to a quantum attack. So their technology allows you to use both quantum safe and existing encryption at the same time, allowing you to phase it in over time, simplifying what could otherwise be a complex, costly process for governments and enterprises. So I would say last year and this year was a pinnacle time for quantum awareness in the world. I've put up a few quotes. Now, what's interesting isn't just the quote, it was the cover of The Economist. I thought I'd share this with you because it captures the sentiment of what's happening. So The Economist in 2017's cover said, after a century stuck in textbooks, mind-bending quantum effects are about to power mainstream innovation. That's in a perfect summary of what's happening right now. And then the Wall Street Journal in 2017, in the past 5 years, scientists have made major progress on the Quantum Computing Balancing Act. In response, investment has surged, with projects underway at Google, Microsoft, IBM, and Intel Corporation, and interest from potential customers has followed. Now, Peter Knight, a leader in the UK effort in 2018, this year, in order to secure the UK lead in this area and make sure that UK companies take a significant share of this large future sector, we must act now with a focus more than ever on working across the spectrum of industry, academia, and government to achieve innovation. Now, as you probably know, I've always been a big believer in the power of science and the power of communication. Bringing people and ideas and technology together to create something new has been a passion of mine for as long as I can remember. Simply put, that's what we're trying to do in the Quantum Valley. Now, what new technologies are possible with quantum? How will healthcare be transformed with quantum sensors? How prepared will industry, government, defense, and society be from the quantum threat? How many new industries will quantum simulators create? How many secrets of the universe will quantum computing unlock in our lifetimes? The work that's being done today, both in Waterloo and around the world, will help answer these questions. What is so exciting about the power of quantum can be summed up with this one insight. Technical challenges that are impossible under classical rules may for the first time be possible under quantum rules. That's another key takeaway. It is for this reason that I'm certain that the second quantum revolution will impact all technologies and industries. I want to thank all of you for coming from your busy schedules to attend this conference. Your contributions today and the continued cooperation and partnerships going forward are vital to our shared future. Thank you.